Okay, in this final video, we're going to go over something called a quadrantal angle to start, and then we're going to look at another application of a trig ratio that's in a different quadrant outside of quadrant 1, where values are always positive. So a quadrantal angle is an angle whose terminal side lies on the x-axis or y-axis. All right, so terminal side is on the x-axis or the y-axis. So how does that impact us? Well, here we want to find 6 trig ratios, and the terminal side of theta contains the point 0, -2. Well, 0, -2 would be here. Okay, so this is a little bit different because unlike the previous problems that we saw, I can draw a line to the origin, no problem. Okay, but that at the same time also draws a line to the x-axis. So that's a little bit different in this case. So what's happening here is we have a value of x, that's 0. We have a value of y, that's -2. All right. And then the value of r, the hypotenuse, remember I always said that was positive. So here x is going to be 0, y is going to be -2, and then your hypotenuse is just the distance from the origin to that point. So that'll be +2. All right, remember this value will always be positive. Okay, now if we go back to one of the previous problems that we looked at real quickly, you can see that in both of these problems that we had, the adjacent side was the x-coordinate. See how the adjacent side is the x-coordinate? And the opposite side is the y-coordinate. Okay? So what that tells me is instead of writing sine always as opposite over hypotenuse, we could actually write it as y, the y-coordinate, over what we'll call the hypotenuse, which is r. Okay? So this is just a different format that gives us the same thing. Cosine adjacent over hypotenuse, we can write that as the x-coordinate over r. And tangent, the adjacent or opposite over adjacent. Opposite is synonymous with y, and adjacent side is synonymous with x. So this is just how we can use the actual coordinates that we're given. It's the same thing, and you can still use opposite, adjacent, hypotenuse to do that, but this makes it more applicable for this type of problem here, where it's kind of hard to see what the opposite and adjacent hypotenuse would be. So remember, this is synonymous with, x is synonymous with the adjacent side, all right? Y is synonymous with the opposite side, and then this is the hypotenuse. So when we go ahead and fill in our 6 trig ratios, it's the same idea. Sine is going to be y over r, or opposite over hypotenuse, so that would be -2 over 2, which would reduce to -1. Okay. The cosine will be the adjacent over the hypotenuse, or x over r, so that'll be 0 over 2, which is just 0. And then the tangent is going to be your opposite over adjacent. So opposite in this case is that y value, -2. Tangent's opposite over adjacent, or y over x, so that'd be -2 over 0. Okay. -2 over 0 is undefined. Okay. Now with our reciprocal functions, we can roll through. The reciprocal of -1 is just -1. Okay. The reciprocal of 0, if we remember way back from chapter 2, the reciprocal of 0 is undefined. And the flip of that, the reciprocal of undefined, is 0. So that's how we can fill in that special scenario for a quadrantal angle. Okay. Now getting back to one where we would have a point that is not on the x or y axis. So we are told in this case that the tangent of b is equivalent to 3 over 4, and the terminal side is in quadrant 3. So that's really important, because when we construct our triangle here, we know that we have to have a terminal side in quadrant 3. So that means our point's actually going to exist here. Okay, so we know that the terminal side is in quadrant 3, so we're going to draw the terminal side there. So again, you might have the case in this problem where this is theta, okay? But what we're actually going to do is construct a triangle in constructing the triangle in quadrant 3 and use the reference angle to find the remaining trig ratios. So again, we know that the terminal side is in 3. I'll put a point there. I draw a line to the origin, and I'll draw a line to the x-axis. Okay, that forms this right triangle. Our reference angle will be between the terminal side and, in this case, the negative x-axis. So we'll be basing everything off of this portion right here. Okay, so in reference to this angle right here, we have our opposite side over here, our adjacent side over here, just like we talked about, the y and the x, and then here's our hypotenuse, or r, okay? Here's the tricky part. Tangent, we know, is opposite over hypotenuse, okay? So in this case, I'm sorry, opposite over adjacent, okay? So tangent is opposite over adjacent. So we would say, okay, well, this is the opposite side, so that's 3. However, we're in quadrant 3. In quadrant 3, both the x and the y coordinates are negative. So that's the trickery of this problem. This would actually be -3. All right. The adjacent side for this one, we look at this and we'd be like, oh yeah, it's 4, but since we went to the left, it's actually -4. Now, that's not always going to be the case. All right, we won't necessarily have to switch the signs. The reason why that happened is if you think about finding the tangent of this triangle doing opposite over adjacent, you would do -3 over -4. That would reduce to 3 over 4. All right, so that's what's key about this one, given this additional criteria that tangent, that the terminal side is in quadrant 3. So be really careful with that. Now, if we use Pythagorean, this is just a 3, 4, 5 triple. So you probably don't even need to do this. All right, so finding the hypotenuse or the value of r, it'll come out to be 5. And again, that value will always be positive. So now we can go ahead and find the remaining trig ratios. All right, we already know tangent, so you could write down cotangent right away. It's just going to be the reciprocal, 4 over 3. That's done. Okay, the sine of theta, opposite over hypotenuse, would be -3 over 5. Its reciprocal cosecant, you would just flip that. It would be -5 over 3. The cosine of theta will equal the adjacent over the hypotenuse, so -4 over 5. Its reciprocal secant will be -5 over 4. So that gives us the remaining trig ratios. Now, the only other thing I'll point out is this one was a special scenario where we did have to change the signs. It won't always be the case. For example, if I had the cosine of angle A was equal to -3 over 5, and A is in quadrant 2, okay, what I would do is go ahead and put a point in quadrant 2, draw my line to the origin, just like we did, drop a line down to the x-axis. That forms our triangle. The cosine is the adjacent over the hypotenuse. The angle we will use will be between the x-axis and the terminal side, so that's our reference angle to the actual angle. And in this case, the adjacent side is -3, the hypotenuse is 5. So see how those signs of those values stay the same. You could use Pythagorean to find that side of 4. Okay?